In this small presentation, we will analyze the working of a simple control loop with an example of a flow control. Any control loop has got three locations for the control action to be completed. Number one, it senses the process value. So there is a sensing location. Number two, the value is reaching the control room where it is compared with the desired process value which the operator sets on the panel. So a comparison takes place in the control room, and depending on the error between the desired value and the process value which get from the field, the controller generates an output which goes to the control valve, which is the final control element. So that is the place where the action takes place. So you have a sensing, comparison, and the implementation, three locations. In the flow control, we measure the flow either by a Norwood phase meter or a Venturi meter, and the output from the meter will be probably in 0 to 100 inches water column or 0 to 2500 millimeter water column. It's a general trend in the industry. You can also have 0 to 50 inches or 0 to 200 inches, but generally it is 0 to 100 inches. This signal goes to the transmitter. The transmitter does what it does is the output is converted to 3 to 15 psi for the pneumatic or 4 to 20 milliamps for the electronic controls, and sends it to the control room. In the control room, the signal obtained from the field is compared with the set value given by the operator, and depending on the error, the control algorithm will calculate an output which has to be sent to the control valve. This output, normally in the DCS, it is in the 4 to 20 milliamps range. Pneumatic controls, it is there in 3 to 15 psi range. The control valve, based on the signal from the control room, either moves towards the closing direction or open direction and adjusts the flow to maintain the process variable at the level desired by the operator. This closes the entire control loop. Since the final control element, that is the control valve, always operates on pneumatic pressure 3 to 15 psi range, the signal from the control room has to be necessarily converted to 3 to 15 range if it is an electronic signal. So we have an I to P transducer if the signal from the control room is electronic signal. Otherwise, the signal from the control room can directly go into the control valve. When you go around the plant, you can see the control valves having basically two colors, red or green. The coloration depends on the fail-safe condition of the control valve. If the valve closes on instrument air failure, it is colored red, and if the valve opens on instrument air failure, the valve is colored green. Normally, red colored valves and failure close valves in the firing circuits, because anything which adds energy, adds heat to the system should go close on instrument air failure. This is just to bring the system back to a safe condition. On the contrary, any valves which remove the heat, remove the pressure from the system, like the refluxes, the vent valves, all are colored green. They are opening on failure. It is very interesting to note that the minimum value for the control signal is never 0. The pneumatic system, it is 3 to 15 psi range, and in the electronic system it is 420 milliamps. So you will find that the datum or the minimum is never 0, it is slightly raised up. This is because of the concept called live zero, dead zero. It's very simple. Assume that an instrument has gone faulty. In that case, it will never generate an output to the controller or the control valve. So if that be the case, the output will be 0. If the instrument is active and the flow is minimum, you get a signal of either 3 psi or 4 milliamps. So the operator understands that the instrument is working, but the process value is minimum. But in the other case, when the instrument is faulty, you get a signal 0. So this is a way you will differentiate between a faulty instrument or the dead instrument and the live instrument. And this concept is called live zero, dead zero, and it has been implemented effectively in the instrument control systems.